All right, I want you to title a new page in your Spiral notebook, Intro to Completing the Square. So this is going to be just a quick little video that's going to go over the prerequisite concepts that we need to know to do completing the square, so that when we do learn about this in class, it can make our class time a little bit more efficient if we can already know this coming in. So what we're going to do to get started here is I'm going to put up 3 different trinomials, and I want you to factor them. So the first one is going to be x squared minus 6x plus 9. The second one is x squared plus 4x plus 4. And then x squared minus 8x plus 16. Okay? So I want you to think about, I want you to individually, I want you to think about how you can split this trinomial, right, into 2 factors. And what you're going to do is I want you to hit the pause key, and I want you to think about how to factor each trinomial. And as you go, you're going to notice some patterns. I want you to start thinking about those patterns, and we'll talk about them, okay? So when you're ready, hit pause and think about how to factor. Go. Okay, so now that you've factored all 3 of these trinomials, let's see if we get the same answer, and let's check your work. So when you went through, we split this into x and x, and I split the 9 into 3 and 3. And so then when we think about factoring that, when we think about multiplying the outer and the inner terms, we notice that it will make a negative 6 in the middle if both of the terms are negative. And so what's going to happen here is when you have x minus 3 and x minus 3, it adds to make negative 6, but it multiplies to make a positive 9. And so actually what we see here is that since we have the same thing twice, we can actually represent this as x minus 3 squared. Okay, so you probably left it as x minus 3 and x minus 3. Why don't you write on your paper this extra step of putting x minus 3 squared? So let's go ahead and when you factor this, let's check your work. You should have gotten x plus 2 and x plus 2 because it adds to make 4x and multiplies to make 4. Well, again, we notice that we get the same thing twice, and we can represent that as x plus 2 squared. So let's check this last problem right here. You factored the 16 into 4 and 4, and if the signs go minus minus, negative 4 and negative 4 will add to make negative 8, but multiply to make positive 16. And finally, for the last time, you can see that again, we can represent this as x minus 4 squared. So in fact, what I've done is I've actually given you the same type of problem 3 times. And these types of problems have a special name. They're called perfect square trinomials because they always factor to be the same factor twice, which means we can then represent it as a parenthesis squared. Okay, so what I really want to talk about this is I want to notice patterns, because within the next couple minutes, I want to be able to factor these and go straight from the original problem to the parentheses squared and not have to do the splitting of 2 parentheses, right? So we want to find shortcuts is basically what I'm saying. All right, so first thing I want you to notice about the original problem, okay? What do you notice about all of these C values or these constant values right here in the trinomial? Well, the first thing I notice is they're all positive, and that will always be true, that the constant is always going to be a positive value. But what do you also notice about the 9, the 4, and the 16? Well, what you should notice about 9 and 4 and 16 are these are all perfect squares. So to have a perfect square trinomial, the constant value needs to be a perfect square. So now I'm going to start noticing between the original trinomial and how it factors. Well, one thing I notice is that when I square root the 9, there you go, I get 3. And when you square root the 4, yep, there's the number in the parenthesis, you get 2. And when I square root the 16, again, the pattern holds true and you get 4, okay? So we definitely see a connection between the constant value and the number that's in the parenthesis. All right, there's another pattern I want you to notice between the original problem and the number that is in the parentheses. The next thing I want you to notice is that this middle term right here, 6, what happens if we take half of 6? And you will see that we get 3, okay? Well, let's keep going and see if that holds true. The middle term is 4. What happens when you take half of it? You're exactly right, you get 2. And so when we start with 8 and we take half, so really what you're going to see is this number right here is always half the middle term. And that's going to be an important concept, okay? Last little pattern I want you to notice is some of the factors have a plus and some of the factors have a minus. How can we already tell whether this sign is going to be a plus or a minus? What do you think? Well, you're probably right if you were thinking here that the middle term is going to be the same sign as the factor. So if there's a negative in the middle, the factor will be negative. Okay, so let's take all of these patterns that we've just talked about and let's see if now we can factor each perfect square trinomial. See if we can do this and go straight to the parentheses squared instead of having to split it into two parentheses first, okay? So let's start with x squared minus 12x plus 36. Let's see, part B is going to be x squared plus 5x plus 25 fourths. And then lastly, let's try one more with a fraction, x squared minus 3x plus 9 fourths. Okay, so take a second if you need, hit the pause key, and let's go ahead and write that down. And we already know that these are going to factor to make a parenthesis squared. So we can already kind of like know that right now, right? Because we understand the patterns. We know what's going to happen is this is going to be x. The middle sign is going to determine the sign in the factor. And then we talked about how this number right here is always half the middle term. Okay, and so you can see here that if I take x minus 6 and x minus 6, it's going to, when I multiply this out, the middle terms are going to add to make negative 12x, and it's going to multiply to make 36x, okay? So I'm not going to keep doing that for all the problems. I just want you to see how this works. All right, let's keep using our patterns because we can pretty efficiently factor these perfect square trinomials even if they have fractions. I know this is an x, I know this is a plus. What did we say again about this number? It's always half the middle term. Well, half of 5 is just 5 halves, okay? I don't even want to write it as a decimal. Don't even write 2.5. Half of 5 is 5 divided by 2. When you multiply this out, 5 halves plus 5 halves makes 5, and when you square it, it makes 25 over 4, okay? So then last problem here, it's going to go x, I know it's going to be a minus, and I always know that this number is half the middle term. So really what this is going to do is it's going to cause us to factor really pretty quickly and pretty efficiently, which is what we need to know for completing the square. All right, last little example. Okay, fill in the blank to make a perfect square trinomial. All right, so let's suppose I give you something like this. Let's suppose that we have x squared plus 10x, and we need to know what does this constant value right here need to be so that it factors to be a perfect square trinomial, okay? Well, what we're going to do is we know it's going to factor just based on what we're given. Based on the patterns, we know it's going to be x plus, and remember we said that this is always half the middle term, okay? And so if I take this number and I square it, if I take this number right here and I square it, then that is what the constant term's going to be, and it's going to be plus 25, okay? So what we're finding is if we take half the middle term and we square it, this is how we get the constant. All right, let's keep going and see if we can keep this going. Let's suppose we have x squared minus 2x plus blank. All right, so let's use our patterns. We know that if we take half the middle term, well, half the middle term is negative 1, and we square it, negative 1 squared is going to make plus 1, okay? And so we're starting to kind of figure out where this constant term comes from. All right, part C. Let's suppose we have x squared plus 7x plus blank. All right, again, this constant value right here comes from taking half the middle term, and half the middle term would just be 7 divided by 2, and then you square it. Well, 7 halves squared is like taking 7 squared and 2 squared, which is going to make 49 over 4. All right, last one. Can you do this last one individually? I'm going to throw in one more odd one. Let's suppose we have x squared minus x plus blank. Okay, see if you can maybe hit pause and figure out what that value needs to be. All right, so half the middle term right here, this is like having a -1. Half the middle term is going to be -1/2. And when you square that, even if it's a positive or a negative, it's always going to make a plus. When you square it, it's going to be like squaring the 1 and squaring the 2. And so we're going to add 1/4 to both sides. Okay, thank you for joining along. I hope that if nothing else, that the patterns make sense and we have a better understanding about perfect square trinomials and all of their patterns, because we're going to use those tomorrow in our next solving method. Okay, we'll see you next time. Bye.